Welcome to my Introduction to Networking course, also known as ITN. This is the version 7 material preparing learners for the Cisco CCNA 200-301. Cisco curriculum, everything is owned and copyrighted by them. So let's get into routing a little bit more in depth. What does routing actually do? Like, what's the functionality of routing? Essentially, routing will take a packet from a LAN and it will transmit it to other routers. That is routing. It makes forwarding decisions. Do I send it out interface A or interface B? That's all part of that forwarding decision. So in this example, we have PC1 trying to communicate with, I believe, a PC2. What ends up happening is it's outside of our network. So we will create a packet, we will create a frame, and we will send it to our default gateway. Our default gateway, router 1, will look at it, look at the data frame, strip it away, look at the packet, and it will look at the destination IPv4 address. And it will figure out where it's supposed to go. If it is unsure, it will send it to its default gateway. If it actually matches a network, here we're trying to send things to the 10110 network, it will then know, oh, this network is attached to another network on router 2. Let's forward our packet to router 2. And so we will then package our packet into a data frame using my exit interface on R1 as the source MAC address and the receiving interface on router 2 as the destination MAC address, and I will put it on the wire. Router 2 will obtain the frame, and router 2 will examine it, strip off the frame, and look at the packet header and realize that which interface to go out of. What's really funny is this address is incorrect. It should be 10.1.1, not 10.1.2, because you'll notice we're talking about that guy. Or it could send it out this other interface, this guy right here, and that'll be to the internet. So the router 2 will have to make the decision which route to take. Because the designer of the PowerPoint did a typo, we know that it should be sending out this interface right here, because this is the network it's supposed to be tagged in. 10.1.2, not 10.1.1. But router 2 is what has to make the decision. Do I send it to the internet or do I send it to my other interface that has the attached network? That is what routing actually does. So there are different types of routing functionality. We have routes that are learned either directly connected, and these are routes that are automatically added to the router, and they are provided by the interface, they are active, and they have an address. So directly connected networks have to have an address and must be on and active. We have remote networks, and those are typically either learned through a routing protocol or statically assigned, manually, static, dynamic routing protocol. And that is essentially, these are remote networks that we can say, oh, I know this network is attached to router 2, I know how to get to router 2, so anything destined for this remote network, I can send to router 2. You will notice on the diagram, this is the directly connected network for router 1. This is a directly connected network for router 2. Sorry. also for router 1. For router 2, we still have that directly connected network for router 2, and we have this network over here being directly connected to router 2. So this middle network, this guy right here, is directly connected to both router 1 and router 2. This being a remote network for R1, this being a remote network for R2. And then we also have a default route. If we have a network designed correctly, we will have a router act as a default gateway for the network that will send it outside of our internal network. Because we could have like a corporate network that allows for communication through our corporation without allowing internet access. Here, our default route will actually be sent to the internet, thus the default route. Alright, so we talked manually and we talked dynamically. So let's talk a little more about how to configure a static route. On the router, we will start off in the global configuration mode. We will say IP route, and we will do remote network, and we will say basically either the next hop or exit interface. So basically, if we want to manually configure R1 to go to this network over here, the 10.1.1.1 network, we could do that a few different ways. We could say forward anything using this network ID and its subnet to this IP address. Because it is directly connected, this is directly connected to R1, so R1 knows that IP address. But if we do that, there is no redundancy. So if this is our network, we got 3 routers, and we were trying to do manual IP configuration, or route configuration. If this link goes down, we won't be able to function. However, we have another path we could take, but because the routes are statically assigned, the router doesn't know how to forward the data. That's a downside to static routes. Dynamic routing actually will determine the best route. So if a path becomes removed, it will forward a different path. We have routing protocols that can actually have the routers share information they know to the other routers. This basically allows us to discover remote networks, have up-to-date information, choose the appropriate path, and recover if there's errors, and find new paths when appropriate. But that means we have to run a routing protocol. Realistically, routing protocols are the way to go, but sometimes static routes are called for depending on functionality. In my line of work, I predominantly do dynamic routing. I very rarely do static routes, but I've had to do them a few times, so you do need to know how they function just in case you need to use them. So, how does the routing table look on a router? If we do a show IP route on a router, we'll get this type of interface. It's a lot of information. First and foremost, this is all codes. This basically is saying, how do we learn routes? Well, we got tons of different ways. Directly connected routes with a local interface will use a L. Directly connected networks will use a C. Notice directly connected local interface addresses are slightly different than directly connected networks. Directly connected networks are going to be the network ID, where the directly connected network with a local address will use the actual network ID without it being summarized. And that makes a little more sense after we've talked about summarization in our IP addressing lecture. The third option is our static routes. They will be denoted with an S. That's typically saved for our default gateways. We have other routing protocols like OSPF or EIGRP or RIP, and they're designated with their own number or their own letters. OSPF being O, EIGRP being D. So we can see what is learned and what is directly connected. You will notice that we have one network learned. That will be the 10.1.1.0 network. We learned that via OSPF, first of all because the O, and because of the metric, the 110, that's what's used for OSPF, and we can say where it's learned from. That's learned from our 209.165.200.226 interface, and we also say how long it's been active. This is just a get your feet wet with the route table. We do way more in-depth lectures on decoding this route table and the functionality and breaking down every portion of this table. We do that in a much later lecture. And that is this chapter in a nutshell. If you have any questions or concerns, please reach out.